name is Jon Hall. I'm the Executive Director of Linux International. And for the people who do not know me, I started off as an electrical engineer, and I switched over to doing half engineering and half business. So engineers cannot lie to me, and business people cannot lie to me. I found out about computers in 1969. That was before there were degrees in computer science. We had computer black magic. And back in those days, there was no computer store. Because if there had been a computer store, you would need a very large truck to carry your computer home. You would need three-phase power to plug your computer in. And you would need a 20-ton air conditioner to cool your computer. I've been using computers since 1969. I worked on mainframe computers for 5 years, Unix since 1980, and in 1994 I met Linus Torvalds and saw Linux for the first time. And I decided that Linux had a commercial use, that Linux could help business, that Linux could help government, that Linux could help the individual person by removing the development of software from certain companies in certain countries to make it completely democratized and around the world, so that people in any country would be able to learn how computers worked and be able to participate in the creation of that software. And that, in effect, draws more industry into your country. Why should you be sending money outside of Sudan to buy software that you can't change, that you can't fix, that you can't make your needs? Why shouldn't you be using that money to pay you to develop software for Sudan, to give you a living? How about software to give you a living as a systems administrator or a programmer? Why should you be paying that money to Bill Gates or Larry Ellison? There's only so many dates that they're going to eat. I have been a university professor. I took students who had never seen a computer before, never touched a computer keyboard, and in 2 years took them from that to knowing how an operating system worked, to knowing how a compiler worked, to knowing how a database worked, and to be able to actually create those types of programs. We didn't know what networking was because networking was carrying a box of cards from one place to the other. But they knew a lot, and a lot of those people are now vice presidents or presidents of their own companies. I believe in fundamental education. I believe you should know what happens at the very bottom of the computer, because later on you will be able to see new things coming out and understand how they work. If all you're ever taught is Java and Microsoft Office or Cisco networking, then when Cisco goes out of business or Microsoft comes out with a new edition, you'll have to have your university degree taken back from you. But if you have a fundamental education, that will last you for the rest of your life. And we'll see more about that later on. These are a few of my friends that I've met over the years. None of them had a formal education in computer science. All of them learned by looking at free software, seeing how it was written, and creating their own products and services. I'll talk about one or two of them. I met this person 2 years ago in Spain. He created his own distribution of Linux at the age of 12 and a half. At the age of 15, when I met him, he had a company that was supporting 20,000 users of his distribution. His distribution was the first one that used facial recognition to allow you to log in. He has now started another company to do courtesy cards for businesses. And I think it's going to be a multi-million-dollar company. This person up here was an English history major in university, but he knew about free software. He helped to start a company called Red Hat Software. Now he's a multi-millionaire. This person down here created his own distribution of Linux at the age of 14. He had another person helping him who was also 14. It was the first distribution that installed into the FAT file system so you didn't have to repartition your disk to store Linux. He had sold 20,000 copies before his parents found out what he had done. And when they said to him, "Why didn't you tell us what you were doing?" he said, "I didn't really need your help." This person right here was running his own consulting service in the town of Soweto, South Africa, a town of 500,000 poor black people outside of Johannesburg. He was communicating with Linus Torvalds, trying to find a problem with the memory management subsystem of the Linux kernel, and they were communicating back and forth. The South African government was so surprised that anybody in Soweto knew anything about computers that they decided to open up an open source development center in Soweto. They had laughed at the concept before that. I'm showing you these people because they've done amazing things. This person created a piece of software called Asterisk. It is basically a very sophisticated telecommunications software that replaces a private switchboard in companies and in businesses. Before he did Asterisk, those things would cost 20 to 30,000 US dollars, which prevented a lot of companies from starting up. His software is now installed by thousands of people around the planet. They don't even have to ask his permission. And he has a company that has 350 employees, and yes, he is a multi-millionaire at the age of 25. Here is my latest hero. He lives in a slum in Rio de Janeiro. He was selling trinkets with his mother on the beaches when he was 8 years old. He wanted to teach himself computers, so he pulled a computer out of the garbage that somebody had thrown out. He took it home and fixed it up. He found books in the garbage about programming. He took them home and learned to program. He decided that the favela needed wireless internet, and people laughed at him. They said, "Nobody will pay you for that." But he thought, "No, I'll do it." He created his own antennas. He found more computers in the trash. And he started selling internet support. Today, he employs 6 people full-time providing that internet support. People are not laughing at him anymore. He started a small school in the favela to teach about systems administration and networking. And he said to me, "Maddog, the kids used to talk about guns and drugs, and now they talk about the internet and the web." The impact of creating a software economy goes beyond just the money, goes beyond just the creation of an industry inside your country. It can create jobs for people which eliminate crime, or help to anyway. So what are the goals of an education? How many people think that you're here so you can get a good job? Please raise your hand. I don't want to pick on you. I think a lot of other people in the room feel that too. But that's not why you're here. The university is not here to get you a good job. The university is here to teach you how to think. The university is here to teach you how to take data that comes in and analyze it to get information, so you can make a good decision about something, so you can innovate with ideas. That is what the university is here for. The university is here to create a thinking workforce and a thinking citizenship so that you can be the leaders of your country tomorrow. That's why the university is here. That's why businesses pay taxes to have the university here. That's why the government puts money to have the university here, not to get you a good job. And this is why we need to think about a lifetime of education, so that people understand the basics of what they're doing, so that they can continue to educate themselves after they leave the university. You should never have to come back to the university again if it has done its job correctly. When you go on for your master's degree, what you're doing is you're picking out a problem that has to be solved and learning how to solve it. Learning how to take that problem down to the smallest part that needs to be solved, that you can solve it in your own lifetime. And your PhD is a culmination of that, plus the moving forward of knowledge. The university is not here to teach you about how to use a particular product. Yes, you may use that product and able to do your work. Use a microscope to help you with biology. Use a telescope to help you with astronomy. You may use a software package to help you do your work. But that's not why the university is here. The university is here to help you think. So in my viewpoint, here's the 4 fundamental paths of an educational body: to set a path of objectives. How do you go from where you are today to what you need to know when you go out into the world? Secondly, once they teach you that, how do you certify that you've actually learned that? What does your diploma really mean? What is the worth of your diploma? It's a piece of paper with ink on it. Think about that. What is the worth of a crown or 10,000 crowns? Same piece of paper, same ink, different pattern, but one is worth 1 crown and one is worth 10,000 crowns. The worth of that is the faith that the person has in that piece of paper to buy something. And the worth of your diploma is the faith that industry and business has that you can actually think and actually help them meet their needs. So the university has to certify that you have learned something. And they do that through tests, they do that through professors talking to you, they do that through projects you do. These are the things that do that. The reason I'm going across all of this now is because a lot of professors I've met in universities say, I need to use closed source products because that's what the industry is using when the students leave. And I want my students to be able to get a good job when they go out there. I have a message for those teachers. Are you telling me that your students are stupid? Are you telling me that your students are bright enough to design a bridge, to design a building, to design an airplane, to design a telecommunications network, and yet they're too stupid to learn how to use Microsoft Office in less than a day or two? You can't have it both ways. Your students are either smart or they're stupid. And once you've learned OpenOffice or K-Office or any Office product, to learn another one, that's less than a day. So please do not teach students products. If you teach your students Windows 3.1 today, and Microsoft comes out with Windows 98 tomorrow, do you knock at the door of your student and say, please give me back your diploma because we only trained you with Windows 3.1. You're no longer capable to use Windows 98. Of course you don't do that. So the concept of using a specific product to teach students how to do something is not the way you should be going. It's not to say you should not teach them Microsoft Windows or Microsoft Office. But what you should be teaching them is how to use an Office product to do your work. And let them compare Microsoft Office versus OpenOffice versus KOffice under that umbrella, so that they can make the proper choice of the proper tool when they get out. That's what you should be teaching them. How to do the evaluation of the tool. That is useful. Now, there are many ways of getting an education, and going to a university is only one of them. I am a product of cooperative education. I went to school part-time and I worked part-time. And the work was actually part of my education. I started out to be an electrical engineer, but it was because of my work I switched over to computers. Why? Because I was almost electrocuted by 13,600 volts and 800 amps. Trust me, you don't want to have that happen to you. And so I switched over to computers. Key punching in an air-conditioned room. It was pleasure. The worst thing that could happen to me was I get a paper cut from the cards. But I learned from this. I learned what an electrical engineer really does. And I learned what computers were through my cooperative education. I learned to program by reading a book and practicing. And there were a few people around I could ask questions of. But that is how I learned to program my first computer. After that, I went on and did less and less electrical engineering all the time and more computers. So cooperative education allowed me to see what the real job was like. And I liked the real job of doing programming. It also allowed me to afford to go to school, because without the cooperative education, I would not have enough money to go to school. Another path of getting an education is through what we call the Guilds program. In a lot of countries, the education at a university is free. But it doesn't mean that people can afford to go to the university, because they still need money to eat, they need money for an apartment, maybe they're supporting their family. And so in England, they have this program called the Guild program, where a student goes up with a master, and the master teaches the student how to do what they're supposed to be doing. The student is actually paid for the work they do for the master. Eventually, the student becomes a journeyman, goes out and practices their skill, and eventually they become a master themselves through doing a project or through doing a paper or otherwise showing what their expertise is. And again, this allows people to be able to get an education if they can't afford to do it the traditional way. Mentorship and self-learning are additional ways of getting the knowledge. After you get any of these methods of learning, you have to go for the certification. And the certification can be happening many ways also. Now, if this is true, if everything I've said to you is true, and your dean has been sitting up here in the front row shaking his head from time to time, then we have to ask ourselves, what should we be teaching? We should be teaching networking fundamentals, not Cisco networking. We should be teaching how to use Office products in your business, not Microsoft Office. We should be teaching databases and database structure and how does that interoperate with the operating system and the hardware, not Oracle database. And we should be teaching telephony, including voice over IP, cellular networks, protocols, not Nortel communications. And people say to me, Maddog, why shouldn't we be teaching Microsoft? It's used on all these desktop systems. It's used on 90% of the desktop systems today. It's used on lots of servers. Well, the last example I gave, Nortel Communications. 3 years ago, Nortel was the second largest telecommunications company on the face of the earth. They had a certification program that people could become certified in the way they did telecommunications. However, the company had a problem. And 2 years later, they were bankrupt, out of business, gone. And anybody that had a Nortel certification was worthless. So even Microsoft, as big as it is, could fall very rapidly. Enron, the largest energy corporation on the face of the earth, went bankrupt in less than 6 months. It doesn't take long. Kodak, for 160 years, Kodak was the photography leader, bankrupt. So how can free culture, what is free culture and how can it help? We talk about free and open source software. What we're really talking about is a method of reducing costs because the software coming out is basically free for you to use, but also to allow real-life projects for students to create that could then be turned into products that can be manufactured inside of your own country. We talk about free and open standards to make this work. Standards that are open to everybody so that everybody understands them. And how do you develop those standards and how do you improve on them? We talk about a concept called Creative Commons. So this is not just about software. This could be about photography. It could be about language. It could be about art. I know that your university has a great art department. This is something that you might think about. I see artwork out in the hallways. License your artwork in a particular way to get yourself known, but also create money. And finally, free and open hardware. Now, in the free software space, there are certain distributions and certain groups who actually concentrate on education. So there are actually two different distributions. One is called Edubuntu, which is a distribution that goes out for kindergarten through 12th grade. It has a lot of programs put onto the distribution that would interest teachers and people teaching to those grade levels. Another one is Fedora. So Fedora, K through 12, kindergarten through 12th grade, Linux. And they have a whole special interest group who is dedicated to trying to make this distribution better and better for young people. Poseidon Linux is another distribution that comes from Brazil. They have scientific and engineering programs on it, including things like geographical information software, statistical packages, mathematics packages, packages for doing physics, packages for doing chemistry, packages for doing electrical engineering, all part of Poseidon Linux. They're supported in a variety of different languages, but there's no reason why you couldn't change that to also have Arabic, because you have the access to the source code for all of them. And we've become very good at making our software translatable to different languages. Let's take a look at a university curriculum for computer science and how free software could be used in that. Let's start off that you're teaching a course in operating systems design. You want to see how an operating system actually works. The very core of an operating system is called the kernel. Linux is an example of a kernel. There are other examples of kernels that each do different things in different ways. And we have a variety of different kernels that are available. We'll start with the simplest one, FreeDOS. This is MS-DOS compatible. You can run MS-DOS programs on top of it. But all the source code is available so you can see how MS-DOS worked. MS-DOS was a very simple operating system, but you can still learn things from it, and it's something that you can introduce to your students. After you've taught that, you can look at Linux or FreeBSD, NetBSD, or OpenBSD. These are more complex operating systems. You'll see in a moment how complex they are. But the students, when they study these, study operating systems that are used by a large number of companies, governments around the world. They're not looking at something that they study as a student, then when they get outside, nobody uses it. There is another operating system called Minix. Minix was developed by a man named Andy Tannenbaum to educate students in how an operating system works. It's a great operating system, but nobody uses it. And so when the students study it, in the back of their minds they know, hey, I'm learning all this stuff, it's great, but when I get out, it has no use. Linux is used by 98% of the world's 500 fastest computers. It's used by over half of all the server systems that ship today. It is used, is the most used operating system in designing new embedded systems, new TVs, new radios, new security systems. It is also the kernel that's used in Android. So it's used now in more telephones than iOS is used in. And it's used in tablets. It's the same kernel that runs on my notebook. It's the same kernel that runs in my tablet. It's the same kernel that runs in my telephone. And so if you learn how that kernel works, you see a large number of people using it. TinyOS is a tiny little operating system that runs in some type of real-time situations. And CMU, Mach, and Herd are microkernels, a different design for an operating system. But it's important so you see how it works and why did people go in that direction. And all of these are free and open source software. Oops, I missed one. But I'm not talking about simple operating systems. I'm talking about things that are multi-user. Linux can handle tens of thousands of users at one time. Multitasking, it can handle hundreds of thousands of tasks going at one time. Multi-threaded, so multiple CPUs can be running through the same application and through the same operating system at one time. The Columbia supercomputer used to predict weather has 10,240 processors all working together on one problem. It's multi-architecture. It works on Intel and ARM. Intel is a complex instruction set computer. ARM is a reduced instruction set computer. It works on PowerPC. It works on Motorola. It works on SPARC. It works on a variety of other systems. Same source code, different systems. Big Indian and Little Indian. It handles them all. 32-bit and 64-bit. Why is that important? Because with 32-bit, you can see 4 billion bytes of data at one time. That's big enough, sounds like a lot, but when you're working on video, you find out that isn't very big. When you're working on weather forecasting, you find out that's not very big. When you're working on simulating an airplane, like a Boeing 747, you find out that's not very big. But 64-bit is 4 billion times 4 billion. How big is that? That's enough to store 128 bytes of data for every square millimeter on the surface of the Earth, including all the oceans. You literally never run out of address space. Why is this important? Because when you do run out of address space, you have to do this thing called edge programming, taking the results from one address space over to the other. This is very difficult and very tricky, so you wish to avoid it. And with 64-bit, you typically can. If you're interested in how file systems work, Linux supports every file system I've ever heard of, including all the file systems of Windows, NTSC, Unix file systems, journaled file systems, log-based file systems, as well as network file systems such as NFS and Samba. Samba is the network file system that Microsoft uses. Linux can support that. So Linux can be a server for Windows clients, Linux clients, and Apple clients. If you're teaching networking, remember Cisco and Nortel? If you're teaching networking, Linux supports every network protocol I've ever heard of. TCP/IP was developed on Unix and Linux systems. X.25, AppleTalk, SMB, we talked about before. All of them, even proprietary ones like DECnet, has a re-implementation for Linux. If you're interested in security, we support a network security model called Kerberos, as well as two different individual security models, SE Linux and AppArmor. Why is SE Linux important? The National Security Agency, one of the government's primary security groups, decided they needed a secure operating system. Did they choose Windows? No. They chose Linux. And they created a model for creating a secure operating system so that they themselves could trust the operating system. If you're interested in graphics, we support the X Windows system, which is a client-server Windows system, as well as OpenGL, which is used for 3D graphics. If you're interested in high-performance computing, the fastest computers in the world, or you're interested in highly available computing, computing that never stops, Linux supports both types of models. This is why eBay uses Linux. This is why Google uses Linux. This is why Facebook uses Linux. They don't use Windows. Recently, NASA decided to move all of their computer systems to Linux because Microsoft operating systems were too unstable for using for space. Virtualization. Linux supports two different models, Xen and KVM. So if you want to see how virtualization can be done, you can look at the source code for Linux. And a wide variety of different emulators for hardware of different types. So even though you have an Intel machine, if you want to run ARM software on top of it, you can through an emulator. But we're not just talking about the operating system itself. What about languages? You want to know about compilers and how they work. Well, all of the different languages you've ever heard of work as free software projects on top of Linux. The only complete implementation of the Ada language in the world is a free software project. All of the languages that you hear of every day, Perl, Python, PHP, C, C++, Fortran, they all began as open source projects and continue as open source projects. C# is perhaps the only language that started as an object-oriented only language. And now even that is open source. Database engines, MySQL, Python. MySQL was a relational database engine. It was not Python, Postgres. Postgres is both relational and object-oriented. Open source projects. CouchDB, open source. Hierarchical file systems, open source. You want to see how they work? All the source code is available to you. If you want to do research on new databases, the open source model is best. Michael Stonebreaker, the teacher who started Ingress and Postgres at the University of California, Berkeley, started them as open source projects and then created companies to provide service for them. Office systems, we mentioned before, there's a wide variety of them. Multimedia tools, you like making videos? You like making audio? There's audio capture programs, editors, video capture programs and editors. There's a program called Blender, which allows you to make a 3D movie or a 3D game or architectural 3D models. The entire software is open source. They've made several different movies. All of the movies are freely available, and all of the intermediate results for the movies are available. So if you want to teach movie making, you can have your students change parts of the intermediate results to see how the final result changes. You don't have to create the entire movie. Voice over IP, very important in today's world, lowering the cost of communications around the world. Most of the voice over IP products are open source. In fact, if you go out to SourceForge, you'll find out that there's 430,000 different sourceware packages out there that you can use in the projects that you're doing. And you don't have to use all of them. You can use some of them. You can go in and pull some of the code out of these projects and use it in your own project as long as you obey the licensing of that project. And most of the time, the licensing only requires that you give credit to the people that wrote the software originally. It's been done by 3.4 million developers around the world. Some of these people only work on this part-time, but a lot of them do significant amounts of work. Microsoft has 70,000 employees. Out of those 70,000 employees, 28,000 are doing sales and marketing and therefore have no useful purpose. So the number of software engineers is probably around 7,000. Compare that to 3.4 million. And you start to see the amount of effort that's happening. And that's without a lot of other countries in the world being fully on board with doing this. We're finding that more and more companies are abandoning a closed source product strategy and turning their code into open source because they've realized that's the better way of making money. What types of programs are out there on SourceForge? I mentioned the audio and video programs they had. There's business and enterprise programs. How do you run your company? A lot of times you use a system called ERP, Enterprise Resource Management. Well, there's open ERP systems available. So you can start your business without having to spend $100,000 with PeopleSoft or $300,000 with Oracle. You can use the software and fill it in. And you can make a living out of showing people how to use that software in their business. Communications. I mentioned before, Astra's voice over IP. Games. There's a large number of games out there. Are these games the same type of games you play on top of Windows? No. But we're rapidly improving in that area. Security and utilities. A lot of security software out there. If you want to become a network administrator or a person who advises people in network security, a lot of the security work is being done in open source. And you can build on top of these programs. So if you're doing research and you require a database, why should you have to go through the licensing stuff that Oracle makes you go through when instead you could be using something like Postgres or CouchDB? It allows you to move your research forward faster. Plus, as you go into the open source environment, you meet other people of similar interests. And perhaps you can collaborate with them to create the software. Mark is a great example. He was going to set up his own support company, and he realized he needed a PBX system to do it. He didn't have the $30,000, so he decided to write his own, and that actually became his business. He was sitting in a conference one time listening to me talk. He was trying to make up his mind whether he should license it as a closed source product or an open source product. He listened to me, he made it open source, and he came back later and said, if I had made it closed source, it never would have worked. My company would have died. But I made it open source, and it made all the difference. So here's a new model of creating software that's actually the same as the old model of creating software when I was a student. Remember, I told you there were no PC stores. There were no boxes of software sitting on a shelf. We paid for the service of people writing software for us. That's how we made our living. And we should go back to that as a service of you taking free software, changing it to meet the customer's needs, and then giving those changes back to the community so that other people can build on top of what you have done, like you built on what top of other people had done. Yesterday, I went to see the pyramids. You know, the pyramids didn't start by putting the topmost brick in place. They had to lay the bricks at the bottom first. And so they always built on top of what the other people had done before. The most important brick was not the one at the top. It was the one at the bottom, because that had to support the entire weight of the pyramid. So you're building on what other people have done before. If you hide that away in proprietary software, nobody can use what you have built to build something better. Here are the things you should be teaching in this new model. How do you do distributed development with people that you've never met before? How do you encourage and get these people to innovate? How do you license your software? What is the best open source license to use, and why does it make a difference? How do you develop formal standards and program against those standards? How do you innovate above and below the standards? How do you keep extending those standards? These are things I never learned until I was far out of university. But these are the things that the university should be teaching you so that you can innovate now. How do you locate and engage a community of people that will help you be successful? These are things you should be learning. And how do you continue to innovate every time and every place constantly? This is how you learn. This is how you move your country forward. So, to the university, I say you should be teaching fundamentals. There's a lot of universities that say, we're only going to teach Java. Nobody needs to know assembly language. I say that's wrong. Because as long as hardware is as hardware is today, you have to know that the disk moves at a certain speed, the bus transfers information at a certain speed, The memory is faster, the registers are faster, the cache is faster. All of these affect your program. And even though you don't program in assembly language, the compiler has to take what you program and change it into that. And you need to know what that means. Once you've known that, then the rest of computer science can keep going, and you will always be able to figure out what's going on. You need to be able to compare and evaluate different packages, different algorithms, different ways of doing things. And this is true in biology, it's true in chemistry, it's true in library science. You need to be able to evaluate these things to decide what's the best path. And how to share your knowledge with other people. There's a lot of people who feel if I share my knowledge with somebody else, that's going to make them as good as I am. There's a flaw in that logic. Number one, your teachers may not know more than you do. Is that strange that I should be saying that? Your teachers are only mortal. You may know things that they don't know, but that's okay, because they know some things that you don't know, and that's what they're teaching you. And they can learn from you as you can learn from them. But the greatest thing that you should be getting from your teachers is the experience that they have in the field that they're in, and the enthusiasm that they have for the field that they're in. That's what you should be getting from your teachers. You should not be learning how to use specific products. There's a piece of software that's very interesting. It's called the Linux Terminal Server Project, LTSP. Now, most of you use laptops with disk drives in them, or you have a desktop with a disk drive in it. And you keep your data on your laptop or on your desktop. But what happens if the desktop fails or breaks and you haven't done a backup recently? Well, that's a problem. What happens if a bug fix for security comes out and you haven't installed it on your system? That's a problem. LTSP says we're going to have a server system that has all the programs and all the data sit on that one server. And when the student turns on their computer system on their desk boots off of the server and takes the programs and the data from that. So the only thing you have to maintain and manage is the server system. This allows the Atlanta Public School System to have 4,400 students with 2,200 desktops and notebooks. They share some. In 31 different servers with only 4 systems administrators. That means 1,100 students are being serviced by one systems administrator. So we advocate this type of a situation for high schools, libraries, and a variety of other places that have a small number of systems administrators and don't have a lot of money. In Curitiba, Brazil, there was a high school teacher who had no money for computers. So he went out to a bunch of banks who were upgrading their computer systems and said, please, can I have your old computers? I want to use them in my classroom. And these computers were so old and slow that they couldn't handle the latest version of Windows. So his students took the computers all apart and put the elements on racks, then put them together. So if an old computer had 2 megabytes of memory here and this one had 2 megabytes of memory there, they combined them to make 4 megabytes of memory. And they built their own computer lab. And they put free software on it. And they had a server system that allowed them to use LTSP. And they learn 3 times. The students learn how to take apart the computer, how to be able to update it and mix the parts together. They learned how to install the operating system. But the greatest thing that they learned was pride. Pride in doing the work themselves, pride in solving their own problem, pride in building their own computer lab. Here's another way of providing a Linux system. Linux can be put on a pen drive like this. And you can boot Linux off of the pen drive, and it runs out of memory and off of the pen drive. It does not touch the hard drive in your computer. You can have the students store their own data on the pen drive. And so after they get finished, they shut the system down, they pull the pen drive out, they put it on a thing around their neck. That's their computer system. They go home, they may have a computer at home, they can put it in, do their work, pull it back out, and take it back to school. So none of the students' data is actually on the computer at the school. It's all in a little pen drive. But they're not carrying a computer back and forth to school. There's nothing for anybody to steal. And so this gives us a certain amount of security to the students because they're not carrying a laptop or something back and forth to school. Now, we also talk about open processes, like creating new standards. You can either create standards in a dark room where nobody can participate, or you can create standards in an open environment so that everybody can participate and give their ideas. We believe in open standards, and we have an organization that promotes open standards in the world. We also believe in separating education, the accumulation of knowledge, from certification, which is the testing of people to see what they know. And we have an organization called LPI that does certification for systems administrators and has a program to allow people to become tested to see if they know what they know. This means that you could be, if you learn systems administration on your own, you could take the test and be certified and get a job as a systems administrator. I'm wearing a t-shirt here called Linux Essentials. This is a new program the same group is doing to teach people how to use a Linux system. They list all the things you should know in using a Linux system, and then you can go and learn those things on your own. Or the university could teach a course of Linux Essentials, and then later on test the people to see if they know that. The latest thing that we've gotten into is open hardware. There are billions of little computers around the world that are called cell phones. And most of these cell phones are closed, even though they're using the Android operating system. The people that make the hardware do not tell anybody how to program the software. They just make the phones and say, you buy them. When the company loses interest in that phone, you no longer can get fixes for it. You no longer can add things to it. It becomes useless. So open hardware allows people to make phones that software people can support for all of time. This is what we're pressing for in the future. We have now 2 little computers, the Arduino and the Raspberry Pi, which are open architecture. And they have open source software that goes on them. And the Arduino is used in real-time controllers, and the Raspberry Pi can run an entire operating system. So both of them have pins on them that can drive electrical circuits where you can design your own embedded hardware, your own refrigerators, your own microwave ovens. And so what I'm advocating is that students start building projects with these. And I saw from your event downstairs yesterday that you are doing that. That's good. But what I want you to do is find your brightest students, have them come together in a group and come up with ideas for new products. Then put all those ideas into a pool and select the best ones. Then have your students work on those as groups. Electrical engineering students working with computer engineering students. Business students working with them. Come up with an entire plan for a business. Then bring industry in and ask them, do you want to manufacture this thing? And create manufacturing jobs inside of Sudan for Sudanese people. You can do this. It's been done many places. You can do it. Creative Commons is a simple licensing model for things like books, photographs, videos. It allows you, the artist, to have control over what you do. In addition, there's Project Gutenberg. Project Gutenberg has 39,000 free English language texts. If you want to teach English as a second language, or even as a first language, why should you have students buying books when they can just download the book from Project Gutenberg for free? And these books are searchable by computer. Versus a printed book, you can't search for a particular phrase or a particular saying. Why not create the same type of model for texts in Arabic? That texts which are out of copyright, so nobody, they don't belong to anybody anymore, are now searchable and available to anybody. So today, even a student who has absolutely no money can get the equivalent of a college education on the net. Does this mean that colleges and universities are going to disappear? No. Because what is a university here for? It is here to allow you to collaborate and meet people and exchange ideas at a very rapid pace. To bring together people who would normally not be together. And to have them exchange ideas. But for the person who can't go to university, or the university that would like to have a subject but can't afford to have a teacher for the 1 or 2 students who want to have that subject, they can reach out across the internet and through the use of free culture, teach that student. One more thing about certification. The paper certification you get, a college diploma or an LPI certificate, is one type of certification. But another type of certification is what we call the portfolio. Artists are familiar with portfolios. You draw a drawing, you keep it in your portfolio. You do some work, write a song, it becomes part of your portfolio. A collection of the works that you have done. But programmers are not used to it. If you do programming for a closed source company, they will never allow you to show the source code that you have done. If you do programming for an open source company, they will always be glad to show your source code. And if it's the right type of company, people can even look at the mailing lists and see the ideas that you created, the conversations that you had, and the way that you worked with other people. So how do you develop this portfolio? You keep track of all the projects you work on as a student. When you go for a job interview, they say, what have you done? You say, oh, I worked on MySQL as a database. You can see my code here. You can see the comments I made and how other people worked with me. You get letters of recommendation from people working on the project that you can put into your portfolio. How many of you know of an operating system called Ubuntu? Ubuntu, a Linux distribution? The person that started Ubuntu, his name was Mark Shuttleworth. Ubuntu is based on another distribution called Debian. Mark Shuttleworth took the entire Debian database down to Antarctica for 9 months. He sat there with a notebook and went through the code and said, oh, this person writes good code. This person gets along well with other people. This person has great ideas. And when he came back, he said, I want you and you and you to come work with me on Ubuntu. No interviews, no resumes, no human relations people. That's how he picked out the people he wanted. And so, if you're doing closed source, he wouldn't have been able to do this. He wouldn't have seen the code you had. He wouldn't have seen the mailing list you had. And you would not have been able to convince him that you were a good programmer. A lot of people say, I want to start my own business, my own support business. Do yourselves a favor. Form a cooperative instead. Pick out other people who have skills that complement your own. Work with them together. You share the same legal staff. You share the same administrative staff. You share the same sales force. But then you all get money according to how much you generate. And this allows you to have the least amount of overhead and the greatest amount of money coming back to you. Companies do not like dealing with a single individual, because what happens when you die? What happens if you go on vacation? What happens if you get hit by a truck? Companies like to deal with other companies. By forming a cooperative, you're able to give them that company to deal with. If you want to go on a vacation, one of the other people takes over support for the company. With that, it's the end of my talk. I'll be happy to answer any questions you have. You've been very patient sitting out there. A few people drifted off, I understand that. So, any questions? Comments? Maddog, you're crazy? It's okay. I've been told that before. Yes, sir.
What are the practical steps we should follow to introduce this system in our university?
Now, are you talking about the university? Okay. If I was a university, what I would do is go through the courses you already teach and say, what free software packages allow us to teach those same courses, and maybe we should have our students using those. Now, some of those free software packages already work on top of Windows, as well as Apple, as well as Linux. So you don't have to change the operating system underneath. You can just change the packages. Then you can say to your computer science students, we've looked at these packages. We think these would be great projects for you to work on. To be able to learn how to work on these software packages that are open source. To start to interact with the other groups that are doing these. At the same time, you might be looking at your computer science courses themselves to say, if we're teaching operating systems, why not teach Linux and FreeDOS as examples of those? If we're teaching compiler theory, why not use an open source compiler like GCC when we're teaching the C language and how a compiler works? Show the students how those compilers are built as examples of compiler theory. By the way, there's just so much to compiler theory, but free software really has some really unique stuff there. How an interpreter is different than a compiler, but you can see it. And you can give the students small tasks. Instead of developing an entire compiler as a project, you say to them, improve this small part. Because that's what's actually happening today. Very seldom do people go in and start a huge project all at once. They go in and they work on small parts of large projects. You're teaching the students how to do that. So these are some of the things you can get started. You might decide whether or not you want to align with LPI. And so if you're teaching areas of systems administration, why not follow the guidelines that are in here, the objectives that are in here. And even if your students don't go for certification, they're still learning what other people have said is important to learn. If they do go for certification, then they're that much closer to getting the certification, even if you don't teach all of it. These are some of the things that you could start doing tomorrow. Not next week, not next month, literally tomorrow. Remember the young person who created the distribution at the age of 14. His parents asked him, "Why didn't you tell us what you were doing?" And he said, "I didn't need your help." He didn't have to ask anybody. He didn't have to call up Microsoft and say, "Is it okay if I make a distribution of your software?" He just did it. It was perfectly okay. You don't have to ask anybody's permission. I went to Turkey a few years ago, and I was in Istanbul. And there's a large number of technology companies in Istanbul. And I said, "Why aren't you doing anything with Linux?" And they said, "We're waiting for the letter of authorization." I said, "What?" He said, you know, the letter of authorization. If you want to do something with Microsoft, you write to Microsoft. First you get a lawyer. Then you write to Microsoft. And then their lawyers write back to you. And then you come up with a contract. And then you negotiate a price. And then there's, and finally you come to agreement. It may be 6 months, 9 months, or a year. And then you can go into business. And they give you the certificate that says, you are the authorized person in Turkey for Microsoft. So we're waiting for that letter of authorization. I says, I've got bad news and good news. The bad news is there's nobody that can give you that letter of authorization. Not even Linus Torvalds himself can give you that letter of authorization. The good news is you don't need it. If you look at the software and the license is right in the software, and you say, yes, I can meet that license, then just do it. You don't need anybody to give you permission. No fees to be paid. No lawyers to talk to. No.
So is it, I don't need authorization?
No, you don't need, just do it. And if anybody gives you any problems with that, you can blame me. This is one reason why the United Nations, as a program, has said that in developing countries, they think that free and open source software is the way they should go. Because I come from a very strange country. I come from the United States. We're strange, I know that. We don't think twice about using Microsoft software because Bill Gates is a loyal US citizen. If the United States says there's a sanction against Sudan, then Bill Gates will not deal with Sudan directly. But he's still a loyal United States citizen. So there's a small country off the coast of Florida. You may have heard of it. It's called Cuba. And for 40 years, we've had an embargo against Cuba. So long that most of us have forgotten that's even there. And Fidel Castro cannot call up Bill Gates and say, "Hey Bill, I have a problem with my software. If you fix it, I'll give you a box of cigars." Which is very important because he makes great cigars. He can't do that because Bill Gates is a loyal US citizen, and even if Bill wanted to help him, he can't. But Linux isn't controlled by the United States. Linux is developed all over the world. The source code is all over the world. Even if SourceForge was blocked from you, there are mirror sites all over the world that you could get the software from. And, you know, this is important because a country cannot use software that's now running its elevators, you know, running its government, and depend on that software to have it taken away from them. If that's what we do, then nobody would use any software. It would be too risky. So the United Nations realizes that free and open source software is a way that developing countries should be going. And this is one reason why Cuba is using free and open source software. It's why Venezuela is using it. I don't know about Iran, but I would assume that they are. Because the United States cannot inflict its will upon that. I don't know all the politics behind, you know, the embargo against, basically against Sudan. But I do know that we will never find peace in the world until people of every country can have a good job, can feel secure from other people. That's important.
Thank you very much.
Sure. Next question. Yes, sir.
Okay.
You have to say very loud.
Okay. I think what you have said is right. All right. I think what you have said is all right. But it is for a very long vision. Okay. Not in this recent time. We need, for example, about 10 years more.
Crap. Crap. 2 years. I took students who in 2 years knew nothing about computers, had never seen a computer, had never touched a computer keyboard, and I taught them operating systems, and I taught them compiler design. 2 years. Just do it today. You can talk for 8 years, you can still do it in 2 years, then you're long term. Or you can never start, and then 10 years from now, you'll be exactly where you are today.
What do you say about the Asian countries like China? They are not learning how to develop software, but they are learning how to have websites of Western countries so they get benefit. So I think quickly than trying to develop it themselves. We can put away moral or basic sides. What do you say about this?
First of all, you don't have to develop all the software here in Sudan. I put a slide up there that showed you 430,000 software packages that people are using around the world today. If you use a relational database system based on SQL, like Oracle, you might be able to use today an SQL database system called Postgres. That database system uses the same language to talk to it as Oracle does. But Oracle will charge you $100,000 US just to start with Oracle. And if anything goes wrong with Oracle, because of the sanctions you have against you, you can't get anyone from Oracle to fix it. If you use Postgres today for your projects, not only do you not have to pay Oracle $100,000 US, but you might be able to find somebody in Sudan, or maybe in Ethiopia, or maybe in Saudi Arabia, who could fix it for you today. I tell a story from time to time. About many years ago, when I was doing a lot of programming, I went into a company and they were doing this thing that could be automated. I said to them, how much would you pay me? Oh, at first I said, how much does it cost you to do this every year? And they said, $2 million US. I said, what if I could automate this and basically bring the price down close to zero? How much would you pay me? They said, we'll pay you 500,000 US dollars. I sat down. In 3 hours, I had written 15 lines of Perl code, which automated the process. I said, $500,000, please. They said, wait a minute, you've only been here for 3 hours, you wrote 15 lines of Perl code, why should we pay you $500,000? I said, you do not pay the surgeon for the 10 minutes they spend in the operating room. You pay them for the 20 years that it took them to learn where to make the cut. There's a difference between cost and value. The cost is what you pay for something in order to have it. And it's very important because if you don't have that money, you can't pay for it. The value is what you get out of it when it works and how well it works. And I believe that free and open source software has a greater value than proprietary software, even if the cost was the same. Because the free and open source software you can change to meet your needs. The proprietary software you cannot. You rely on other people. In Sao Paulo, Brazil, or in Brazil, they have a lottery system. The lottery system makes a lot of money for the government. They ran it off of proprietary code that they got from a company. They paid that company $1 million US every month to maintain it because it's important that that code worked. When they wanted to have a new game, it took them 10 months to get the new game because that's how long the company said it would take. So they switched over to free and open source software. They hired 3 open source programmers, and they replaced the entire lottery system. And now they found out they could have a new game in 3 weeks, not 10 months. Do you know how much money is generated when you have a new lottery game in a country of 194 million Brazilians who love to bet on sports? A lot of money. A lot of money. A lot of money. Don't say it's going to take 10 years. Don't say it's a long-term project. After World War II, Liechtenstein was the poorest country in Europe. Their king came up with a plan and sold the plan to his people. And in 10 years, they went from being the poorest country in Europe to being the richest country in Europe. Malaysia was the poorest country in Asia. They had a prime minister who came up with a plan, and in 25 years, they went from being the poorest country in Asia to being the richest country in Asia on a per capita basis. Ireland was one of the poorest countries in Europe. They came up with a plan, and in 5 years, they became one of the richest countries in Europe. But you have to come up with the plan, and you have to execute it today. Don't wait 5 years. Don't wait 10 years. Don't say this is a long, because it's not a step function. Liechtenstein didn't go from being the poorest country for 9 years and 11 months, and then all of a sudden become the richest one. After they started to implement their plan, their economy grew like this, as did all the other countries. So don't say it's going to take 10 years, it's long term. And you don't even have to have anybody doing this. Anybody in this room can come up with their own plan. Because your state bank right now is using Linux to run it. Your libraries are using Linux to run them. Right now. You just have to catch up with this. I'm sorry, I didn't want to pick on you, okay? But I'm tired of hearing this long-term plan thing. None of those people I showed you on that slide had a long-term plan. The kid in the upper right-hand corner, he kept saying to me, Maddog, I'm in this for the short run. I'm only here for a short time. I'm an English history literature student. I'm just doing this for a little bit. I says, Eric, you don't understand what you're doing. But you will be a multi-millionaire out of this. And he laughed at me until he became a multi-millionaire. Next question. Yes, ma'am.
All of the people in Sudan, they try to use only the SPSS for data analysis.
SPSS, right?
Is there any other packages for data analysis in Linux, for example?
I would suggest you take a look at the language R. R is very good for statistical language, and Anwar is agreeing with me over here. And it's absolutely free and open. And there's also other statistical packages which are available, but R is probably the most famous and best supported. Okay? Next question. By the way, if you go to SourceForge, you'll find out that all the programs there are very, very carefully categorized. And so you look for mathematical packages, there's statistical packages, and so forth, and you can find a lot of packages. And then you look for how many people are downloading them and how these people have graded each package. Each package comes with a description of what it does, so you can find the most likely packages to meet your needs. Then you give one package to each one of 5 students and say, you help us determine which package we really should be using. And then you get the students to do the work for you. And they learn and you benefit. Yes, ma'am.
About the software in Linux,
I can't hear you because the fan's going and stuff. Okay.
You speak about the software, but the thing what I want them to know that Linux have so many free sites in information.
Yes.
And they can use it. All the students and the teachers and those who are here, I want them to know that Linux is the best site for free data.
What she said was that she wanted everybody to know that Linux is really a jumping off point for other sites that have free information around the world. So we have free magazines which we create. And these magazines can help educate you. There are lots of PDF books that people have written and put them up on the web for free. So the Linux Essentials course, this one I have on my t-shirt, there's actually an entire training manual for Linux Essentials on the site that you can pull down for free and use. There's training manuals for the other Linux certifications. Those are a little bit more scattered. You have to search for them, but they are there. And there are things like forums where you can ask questions, and a lot of people who are helpful and will give you back answers. Sometimes you have to differentiate between the data and the information. Sometimes you have to think about it and say, does this answer actually meet my needs? But that's your job. And nobody can determine what answer is best for you except you. There's another question. Yes, sir.
Why they prefer Linux?
Louder.
Why they prefer Linux and
Okay, I heard Linux and Microsoft and products, but
why they prefer Linux and Microsoft products?
Okay. The question was, why do I prefer Linux over Microsoft products? As a product, you may not. As a product, which is something you just use, you might say, I prefer Microsoft more. However, if there's something about Microsoft you don't like, you can't change it. You have to try and convince Mr. Gates or Mr. Ballmer that you want to change this, and then you have to wait for them to change it. If you're a business person, the longer you wait, the more money that costs you. If you're a government, the longer you wait, perhaps more people are breaking into your system. Many years ago, I was working for a company, and we had an operating system we made. There was a virus that was attacking all of the operating systems that were Unix. And people were breaking into people's computer systems. It took my company 3 weeks to create the patch to fix that problem. So until that came out, our customers were having people break into their Unix systems. In the free software community, it took them 3 hours to create the software patch for the systems. And so the free software people were able to protect their systems 3 hours after the virus started to attack. 3 weeks, 3 hours, which is better. And we had an older operating system that we had dropped support. It was kind of like Windows 98 or Windows Me or Windows 2000. We were no longer making patches for those. Those customers were out of luck if they needed to use that. Microsoft is going to drop support for Windows XP next May. No more patches. No more putting Windows XP on new systems. All the people who like Windows XP and are still using it are out of luck. They will have to go to a more modern version of Microsoft like Vista or Windows 8. And it's not saying that those new operating systems will work on their old hardware. So they might have to buy new hardware to put these newer operating systems on. There's no guarantee that their applications that worked on Windows XP will work on Windows 8. There's no guarantee that the hardware, the specialized hardware they were using with Windows 98 is going to be supported on Windows 8. Maybe the company that made that hardware is out of business. With Linux, you get the source code for the operating system. And you can make the applications. With free and open source software, you can make the business decision about whether you continue to use the software the way it is, or whether you pay to have it upgraded to meet your need. But that's your decision to make. Not Steve Ballmer, not Bill Gates, not Larry Ellison. Your decision. Any other questions? Yes, sir. Linux and Unix?
Yeah.
Unix was an operating system created by AT&T, but it had a license on it that meant that you couldn't really give out the source code a lot. Linux is a re-implementation of that. It looks a lot like Unix, it acts a lot like Unix. You program it much the same as Unix, but it is a re-implementation without the problem of having to pay for the source code. So the answer is basically no. There isn't any real difference between Unix and Linux. But it's a different pieces of code. If you learn stuff for Unix, you'll feel very much at home with Linux. And if you learn Linux, you'll feel very much at home with Unix. It's not like the difference between Microsoft Windows and Unix. Yes, sir. Louder, louder, I can't hear you.
There's a lot of companies. A lot of companies with Linux.
Are there a lot of companies, large companies using Linux? Yes. Every enterprise company I know of uses Linux someplace in their company.
So why they want to?
For a variety of reasons.
Why they really want to do that?
Okay. Microsoft developed their operating system at first for a desktop, a personal system, personal computer. That's where we get the word PC. But personal computers have different needs than server systems. They hadn't designed Windows to be a server system. Windows NT came along, and that was their attempt to do a server system. But they were trying to make Windows NT look a lot like Windows. And this is a big failure. So their systems are less stable. They do not scale as well. Microsoft is great in a small or medium business, but you'll never find eBay running the servers with Microsoft on them. Out of the 500 fastest computers in the world, only one of them runs Windows. And that's because Microsoft pays them to run Windows. Otherwise, you'd say all 500 fastest computers run Linux.
Okay, Windows, say Windows, Microsoft is not.
Don't get softer just because I'm closer to you.
Microsoft is not, the software is not secure. Is this right or?
Also, security is a problem, right? It's because Unix and Linux systems were designed to be more secure. Unix and Linux systems were designed by engineers who are paranoid. Okay? Windows systems were designed to be easy for people to use, but that can also create security holes. So for example, you as a Windows user might download something from the web, and automatically it will start to execute. Typically in a Linux space, when you download something, it first asks you, do you want to execute this? Okay? And there's protection of the kernel of the operating system from what you as a user do. So you cannot write into the operating system. And any program you execute cannot write into the operating system. The operating system has to ask you for the information. And when you give it to it, it looks at it very carefully to figure out whether or not it's actually going to let you do it. Okay? Okay.
Actually,
Yes?
actually, sometimes I hear that Microsoft itself uses a Linux server. Is it true or not?
I do not know what happens inside of Microsoft and whether or not they use a Linux server or not. I can tell you that when they tried to implement their TCP/IP software inside of their own kernel, they actually took that software from BSD because BSD had implemented it better than they could. So, and the BSD license allowed them to do that. They could not do that with Linux because if they did, they would have to open up all the source code for their operating system, and they weren't going to do that. Yes, sir.
First of all, welcome you in our college. I'm glad to have you with us today. My question is, does Linux support all extensions of files that Windows XP supported for the Windows?
Does Linux support all the extensions for what?
For files that's
File servers, file extensions.
That's Windows supported.
Yes.
All files, all extensions.
Well, it depends on whether the extensions are proprietary or not. I mean, we have to be told what these extensions mean and what they do. What types of file extensions are you talking about?
Like exe files.
An exe is an executable,
Yes.
okay? So the executable isn't necessarily executable on Linux because you have different interfaces that it works with. There is a Windows emulator called Wine that when it sees an exe interface will actually try and run that binary on top of Linux. But because some programs do things down inside of the Microsoft kernel, and we don't know what that is, we can't support every program. But major programs, for example, Microsoft Office, can actually work binary compatible on top of Linux. And we even have companies that sell support for that to happen. But other extensions like .doc, that's supported by OpenOffice and a variety of other Office packages. The extensions for Excel, the extensions for PowerPoint, PPT, those are automatically supported by OpenOffice as an Office package.
Another question. Does Linux have a version called Red Hat?
Yes, there is a distribution called Red Hat Linux, yes.
Okay.
You're welcome.
Another point. Your slides you presented give me a lot of motivation to improve my skills in Virtualization.
Well, thank you. Okay, any more questions? Yes, ma'am.
How did you get the Linux idea? How did you invent it?
Well, first of all, I didn't invent Linux. It was invented by a young man named Linus Torvalds, who was a student at the University of Helsinki. When he was 21 years old, he decided he wanted to write a new kernel of an operating system. And it was just for fun. It was a hobby. It was something he was interested in. And so he gathered together a group of people that wanted to help him do this. And I met Linus, that was in 1991. I met him in 1994 when Linux was almost ready to go out for the first release. And I saw it and I realized this was a good thing. And I helped to promote the Linux system for commercial use, not just as a hobbyist system and not just as a educational thing. So I didn't invent Linux, that was Linus's thing. And there's also an organization called the Free Software Foundation. They started in 1984 with a project to create what they called the GNU operating system. And they created things like compilers and command interpreters and utilities and things like that. There's a project from MIT called X Windows. They created the windowing system. And then there were other projects, there were also free projects, like from the University of California, Berkeley. And all of this stuff comes together into a package, which we call a distribution. Now, the young man there mentioned Red Hat as a distribution, but there's also Debian as a distribution, and Ubuntu as a distribution. And they take all these parts and put them together in a certain way that some people like. Some people like Red Hat, some people like Debian, and some people like Ubuntu. And people say to me, what one do you recommend for me? And I say, I don't have an answer, because I don't know you. I don't know what you want to do. I put a distribution up there called Poseidon, and I told you it was for scientific work. But I don't know if that's what you want. Maybe you want something different. They're all free. You can pull them all down off the internet, try them on your computer, and whichever one you like, that's the one you use. And you can also go to forums and read about them. And maybe from that, you can figure out which one you want to use. You can ask other people, hey, are you using Red Hat? Can I see what that looks like? And they show it to you. You say, I like that. That's the one I want to use. But that's up to you. And I can't tell you which one to use. Yes, ma'am.
I can just, I don't need an authorization letter to do that.
No, you don't.
From Saudi Arabia. Does this mean there is no any organizing or controlling measures for the system? Anybody can fix it?
Anybody could fix it, yes. And what we recommend is that when you fix it, if you find a problem and you fix it, you give it back to the developers who can then incorporate it into the next release that comes out. No, you don't need an authorization. You don't need an authorization. Any other questions?
How old is the Linux system in operation? How old?
How long?
No, how old? When did this system start?
Well, that's a very long story. Can I use the mic, please? He asked, how long has this been going?
Yeah.
How long has Linux been in existence? That's a very complex question, because in 1969, I was a university student, and I couldn't afford the 100,000 US dollars it would cost me to buy a compiler. So I got my compilers from an organization called DECUS. That was an organization of users. And they wrote software to fix their own problems. They wrote software to meet their own needs. And when they got finished with it, they said, maybe I could sell this, but selling software is very hard. You have to write documentation, and you have to supply support. These people were not professional programmers. They were physicists, they were educators, they were doctors. And so they contributed their software to this library called DECUS. That was for DEC. There was also libraries for IBM called Share, and libraries for Novell called Brain something or other, Brain Warp or something, I forget. But these libraries then redistributed that software to people that wanted them, basically for the cost of the media. And the media at that time was paper tape. So for $5 US, I could have a compiler on paper tape. But $5 US for a college student in 1969 was a lot of money, because I could buy 10 pitchers of beer. And so I had a choice between a text editor or compiler and 10 pitchers of beer. I think you can see what direction I would go. So I would take my compiler and I would buy new paper tape from the school store, and I would make copies of it. And I would sell it to my roommates for $1 a copy. And by the time I made my 5 copies, or maybe 6 to cover the cost of the new paper tape, then I had both my compiler and my 10 pitchers of beer. If I made another 5 copies, I could have another 6 copies, I could have another pitcher of beer, 10 pitchers of beer. So I was selling the service of making these compilers. And most software back in those days was open source. People didn't build a binary because every computer system was different. And so when you bought a software product, they brought it to you in source code form, along with an engineer who would then compile that program onto your system. That's why it cost $100,000. But in 1977 to 1980, Apple II, the personal PC from IBM came out, and people said, now we're stamping out computers like cookies on a cookie sheet. So maybe we can stamp out software the same way. And that's how the software business started. Now, in 1984, there was this guy at MIT named Richard Stallman, and he didn't like it that Unix systems were going from being distributed in source code to being only binary. And so he started up a program called GNU, which stands for GNU is not Unix. And he wanted to create an entire Unix operating system that was source code available. And he started by writing a text editor called Emacs. And Emacs was very popular and went across a wide range of other systems. Then he created some compilers, which became known as the GNU compiler suite, C, Fortran, Pascal, and a variety of others. And they became very popular. They developed a lot of utilities In the meantime, there were other universities like MIT and Carnegie Mellon who were also contributing and Berkeley, large amounts of free software. And all of this started to be gathered together, but there was one part that was missing, and that was the kernel. If Richard Stallman had started with the kernel in 1984, by the time everything else was ready, the kernel would be uninteresting. So he started with things that everybody could use. And then the only thing that was missing was the kernel. Richard started a program called the Herd, which is a microkernel. But microkernels are very difficult. At the same time, a student in Helsinki, Finland, Linus Torvalds, started a project in 1991 called Linux. And that became the Linux kernel of today. So this is why some people call Linux GNU Linux, recognizing the contributions of Richard Stallman and the Free Software Foundation and Linus Torvalds, the creator of the kernel. Now, you take all of these parts, and again, you don't need permission to do this. So you take all of these parts and put it together, and we create what we call a distribution. And some distributions are funded by companies like Red Hat and SUSE, and others are complete community projects like Debian. There is no Debian company. There's no company that makes Debian. It's all community. And then there are kind of half in between. There's Ubuntu as a community project and Canonical as a company that helps support it. There's Fedora as a community project and Red Hat Linux as a company that supports it. And there's OpenSUSE as a community project and the SUSE operating system. So companies and governments that feel better about buying free software from a company because they say I can get support, things like that, they buy it from Canonical and SUSE and Red Hat. And people who want the operating system just for their own use or to run in small projects and they don't have a lot of money, they get the free copy, which in a lot of times is exactly the same as the commercial copy.
So, you are the founder of this system?
No. No, no. No, I'm not the
First
founder.
system.
I've just benefited from it for 43 years. In 43 years, I've never bought a piece of software that I needed to use, ever. Except for the $5 I paid to Deacon's, so I got my 10 pitchers of beer. And there I wasn't buying the software, I was buying their copying it for me. They're holding it in a library and copying it for me. I am Executive Director of Linux International. I helped to found LPI. I helped to found the Linux Standard Base Project, which is a very important project inside of Linux. And I helped to protect the Linux trademark when somebody was trying to take it over and blackmail Linux companies. So those are the things I did. And for the last 20 years, I've been going around and talking to groups like this, trying to convince universities and governments and business that free software is actually the best thing for them. This work I do without honorarium. I do it for free. I ask that people pay my travel and expenses. But I earn my money by doing consulting. So right now I'm doing consulting for a company called ARM that makes the ARM computer. And I write magazine articles and things like that. But I don't make any money out of being the executive director of Linux International. That's my contribution back to the Linux community. Thank you. So I think the next step for all of you, there are books that you can pull down off of the internet to help you learning about Linux. And these books are free. And you can pull Linux down off the internet and install it on your own computer. You don't have to erase Windows. You can have Windows on one part of your disk and Linux on the other, and you can dual boot. Or you can run a virtual machine on your system and run Linux on top of that. I actually recommend that you run Linux on your notebook and put Windows in your virtual machine. It'll be a lot more stable. And you can start looking at SourceForge to see the programs there. And believe me, there are programs there that even if you decide to use Windows, these programs are very good and will help you instead of having to pay a lot of money. Because you may pirate software now, but when you go out into industry, if you work for the government, they can't afford to pirate software. And they will be paying for that software. That means they have less money to pay you as a programmer. So if you learn how to start doing this stuff with free software right now, you will be more valuable to your government and to your companies when you leave. A lot of times Microsoft gives software to universities and to schools, and they say, here's some software. Go and use it. You don't have to pay us for it. It's okay. It's legal. And the school says, oh, this is wonderful. We get to use this software for free. No, they don't. Because if the government and the universities use closed source software, their suppliers and the people that work with them also get that software. But they have to pay for it. And then when they sell you things, you have to pay them for the fact that they're using the proprietary software. If they were using free software, if you were using free software and they were using free software, now you can exchange your documents and everything. But they can either have more money to make more profit or charge you less for the things that they're selling you because they don't have to pay Microsoft. There is no such thing as a free lunch. There is no such thing as completely free software. Even a mother's love has a cost. If you love me, you'll take out the garbage. If you love me, you'll feed the cat.
Clean your room because you love me.
There is no such thing as free software. Completely free. But it's a lot less expensive and gives you much more capabilities than closed source software does. Okay, thank you very much.
You can come here. So, on behalf of College and the IT department, I'd like to thank Mr. Jon Hall for his valuable visit to Garden City and the lecture he gave. It was an interesting discussion that everyone got involved. The message here is, the free open software is the direction that we should embrace and go for. Someone mentioned that we need a long-term strategy for 10 years or so. I guess it's a short one, and the plan is to start now. We, as a TEDx Khartoum team, we also owe a great deal of gratitude to Mr. Jon Hall for coming and giving a talk on the last Saturday, and then the extension of his trip where he visited universities and colleges and gave lectures to spread the awareness. Yesterday he suggested that we can host a conference around free open software in my hometown, Port Sudan. That would be great.
I didn't know it was his hometown.
Yeah. And then we hope that every stakeholder could participate and contribute this idea from the early beginning. Once again, thank you so much. Yeah, Sudanese people and the Garden Cityans and everyone gives you a warm thank you.